Hello all, welcome to Coder. Let us solve today's LeetCode daily challenge, and the problem is maximum length of the repeated subarray. Given two integer array nums1 and nums2, return the maximum length of the subarray that appears in both the arrays. It is a straightforward question. Yeah, they have given two arrays 1 2 3 2 1 and the other array 3 2 1 4 7. So what is the longest length, maximum length subarray? Subarray that is equal to, that is common for both the arrays, that is 3 2 1, which is of length 3. So 3 is our output. And considering the example 2, the array is 0 0 0 and another array is also 0 0 0 0, and the maximum length max length subarray is 0 0 0 0 0, which is the of length 5. So this is the problem. So first let us think of brute force approach. What will be the brute force approach? There for each and every index 0 to n in nums1, and I will go and search for j. J starts from I, which is also ranging from I to m in nums2, and again there will be another for loop. If nums of 1 nums1 of I is equal to nums2 of j, then I will be incrementing the length and update our final answer. Update our answer equal to max of answer comma length, and finally just return our answer. So this will be the brute force approach. So the time complexity will for this approach will be order of n cube, and the space complexity will be order of 1. So how can we optimize this approach? This is our brute force solution. So let us think in some other way. Consider we are going to take all possible ways in the sense I'm going to explore this two arrays in all possible ways. So consider we are having the array 1 2 3 2 1 and another array 3 2 1 4 7. So one possible way of finding one possible maximum length array is 3 2 1 only, that is the maximum length subarray. And if we are having an 1 here and here also we are having a 1, then obviously the length will become 4. So let us take some other example and see what we can take. 1 2 3 2 1 2 1 4. Let me consider this array. So consider we are having an array of like this 2 1 4 7. So what will be the maximum length of this subarray? What will be the maximum length of the common subarray? Obviously we can take one particular subarray is 2 1 4 7 and another particular subarray. This is one way. Another subarray is 2 1 4 7 3 2 1 4 3 2 1 4. So this is another subarray. So this is the maximum length for this example is obviously 4. So how can we, since I'm taking all possible ways, I'm going to think of some recursion solution where we can implement by taking all the possible ways. How can write the recurrence relation? Let us go for it. First we can represent two arrays in terms of their indices. So first there are two arrays, so obviously we are going to represent it in two indices I and j. So I'm going to call the from the main function I'm going to call the function solve nums1 nums2 with passing the 0 comma 0. So I will call this function return nums1 return solve of nums1 nums2 and with index 0 and 0. So I am saying that this function is going to return me the maximum length subarray, maximum length of that subarray, which is common to both the arrays. So what will be the recurrence relation? The recurrence relation will be if there may be two options. If my nums1 of I is equal to my nums2 of j, then I can have one option, which is solve of nums1 and nums2, and since both the elements are equal, that is this 3 and this 3 is equal, so what I will be doing is I will be moving both I and j. So in my next recursive is called, so I plus 1 j plus 1, this will be my option. Else there will be another two options. Either I can move one pointer I plus 1 or j plus 1. So option 1 will be solve of nums1 nums2 I plus 1 j remains same, and there will be another option I j plus 1. So this will be the two options. Let me name like this: option 1, option 2, option 3. So but whenever I am doing that, I cannot carry a 1 here, because if I do one, if this is equal, I'm going to increase the length of the subarray by 1. So if I add 1 plus, then obviously this may become a subsequence, so I should maintain it as a subarray itself. So I will be taking an extra parameter and going to pass the length as well. So length plus 1, whenever two elements are equal, then the length of the subarray will be incremented by 1. Whenever it is not equal, the length of the array again starts from 0, because I am calculating the subarray which is contiguous. So finally I am going to return the maximum of all the three options: option 1, option 2 and option 3. So this will be my recurrence relation. So let us try to code this and check whether it is running. So I'm going to get the size of the array nums1 dot size and int n equal to nums2 dot size, return solve of nums1 nums2 0 0, and the length of the subarray starts with 0 and m and n. This is going to return me the maximum length subarray. Then going to define the function solve. Int solve vector int function nums1 vector int nums2 int I int j and int length. I will name it as length, and this m and n are the size of the array. What will be the base condition? If my I has reached m or my j has reached n, obviously I am going to return 0 because they have exceeded the boundaries. Or else what I can do is I can have three options: option 1 0, option 2 0, and option 3 0. If my nums1 of I is equal to my nums2 of j, then what will be the recursive function? Option 1 is nothing but solve of nums1 nums2, both I and j will be incremented by 1, and my current length is incremented by 1 since the current element is equal in both the arrays, and m and n as well. Else there will be two options: either I can move or j can move. So nums1 nums2 I plus 1 j, and length starts from 0 because it is contiguous mn. And this is option 2 and this is option 3. Here option 3 I will be remaining the same and j will be divided by 1. So finally returning the maximum of all the three, option 1 comma option 2 comma option 3. Yes. Okay, let us try to run our code. This will be the recursive solution. Here the time complexity will be exponential definitely. Let us see what is failing here. Okay, actually we are actually updating, we are actually having this as a parameter. I'm not this function is not going to return me anything. This function is just having the answer as another parameter. So I should have a global variable. I will declare a variable answer and I'm going to calculate this answer as length. This answer is max of answer comma length. So now let us write, oh no, finally I should return answer only, return answer. Now it should be correct because I'm updating the answer now here. Answer is and answer comma length. Okay, let us observe what is happening here. What will be the problem actually? Even if it is not same, I should run both this option 1 and option 2, I guess. So actually we don't want to have an global variable because this may be very tough to convert it into a memorization because we are having a global variable. So we'll try to change our recursive solution itself. Whenever I come inside this loop, I'm going to have one variable in answer which is going to store the length. So what I'm doing is even I'm returning the maximum of all these options, either answer or option 1 or option 2 or option 3. So finally I'm just returning this function. So this, let us see whether it is working now. Okay, we are getting one less than. Okay, what is happening here? Okay, this it is quite, since recursive solution it is quite tough to trace, but let us see. This option 1, I will name this option 1 to be length because this option 1 is considering when it is same, else it is not same. So it should start from the length, start from the current length, or else it will be definitely wrong, right? It will be not clear if I'm naming like this option 1, option 2, option 3. If this is equal elements, equal elements means it should start from it is we have calculated, you consider we are in some recursive call, and during that recursive call we have calculated a two length subarray, and even now the current length subarray is also equal. Current element in both the arrays is also equal, then the 2 is going to become 2 plus 1 3. So this if condition should be having the same variable, right? So equal elements should be calculated as nums1, nums2, I plus 1, j plus 1, and the current length will be incremented by 1. So that the equal elements will store the current length's value, the incremental length. And this option 2 and option 3 can be 0 initially, or else I can declare here. I can declare here. I don't want option 1, option 2. I will declare another variable name. Let us say different elements. Different elements from n1, and similarly this is different elements from n2. That there are two options, either I can move forward or j can move forward, staying I and j, and the length will be starting from the 0. So finally I'm going to return the maximum of this equal elements, different elements, and different elements n2. So this will be our case, right? Yes, I guess, because before previously I have initialized this equal elements to be 0. That is completely wrong, because each and every time this equal elements will be starting from 0. Let's try to run this code and see whether it is getting accepted. What is happening? Am I missing somewhere something? Okay, let us. Okay, finally, if this I or j is reaching the size of the elements, I should return the length, or else how it will get computed. Yes, since I'm carrying it as a particular parameter in this recursive function, obviously I'm going to return this length. I should not return 0, or else it will give us wrong answer, right? Yes. That is that is that is the problem here. Yeah, I have returned 0 when I reach the length. I'm just returning 0. Then I'm not calculate. I'm not taking into this account this length itself. Okay, now let us try to memorize it. We should see what are the changing parameters. There are 3 parameters changing, so we are declaring a 3-dimensional array vector int dp of size m, and a vector int of size n, and another size vector of int, which is I can say it as 1001 minus 1, because the maximum length of the subarray will be 1000 only if all the both the elements having a 1000 length equal elements. So now let us pass this parameter as in our recursive function as well with reference, and I should pass in all the recursive calls dp dp dp, and I should consider one case. Dp of ij of length is not equal to -1, then return dp of ij length and I should memorize it. If my dp of ij is already computed, I should cache it. So now let us try to run our code. This will be the memorization, and the time complexity here will be order of n into m into this length. So let us try to run our code over the example test cases as well. So it gets accepted. Let us submit the code. I think it will get memory limit exceeded. Yeah. So as expected, we get the memory limit exceeded. So see how to how to optimize this. So we should eliminate one dimension, so we can have 2-dimensional array vector of vector int, and this is of size vector of int m comma vector of int of size n and minus 1 initially, and this will be the two-dimensional array of dp, and I have eliminated this length. So how I should do is I should have a reference variable answer, and here I will declare answer to be 0 initially and passing this answer, and finally I'm returning the answer at the end of the day. So I'm going to call this recursive function now. Now what I'm doing is answer, and this will be whenever I reach the end of the boundary I'm going to return 0. If there is an equal element, then I will be adding one step to that element, so that I am so that I am calculating the length as well. So whenever there is a two equal elements in both the arrays, the length of the subarray will be increased by 1. And then initially the int cur equal to 0, the current length will be 0, and this current length will be updated here. Instead of this current length, this equal elements itself we can have it. Answer equal to max of answer comma the equal elements, and finally returning the maximum of equal elements, difference 1, difference 2. But here we don't want to calculate this because we want to memorize it in such a way that it is storing only the subarray, that is contiguous elements. So we don't want to, even we are taking these two elements, we want to store the elements which is having the length maximum length subarray, so we can just store this equal elements into the dp of ij in that is to the index I till j. There is a length of subarray equal elements, so this will store that, and dp of ij is not -1, then we can just return -1. This what it represents is dp of ij represents the maximum length of the subarray that is found from the length of the array nums1 from 0 to I, as well as the length of the nums2 from 0 to j. So that I'm the maximum length I'm storing. That's it. So now let us run the code. Oh, this parameter is answer. Now let us run. Okay, it gets accepted. Let us submit the code. Hope this will get accepted. Yes, it gets accepted. Hope you like the solution. Even now we can memorize it, we can optimize this approach into a tabulation form. Let us see that as well. So we can just make this initialize this -1 to be 0, and there is a 2D array initially 0. What I am going to do is, now we have to take care of the base condition. Whenever the I has reached the boundary or j has reached the boundary, I am just returning the 0, that is for each and every loop, for each and every I int I equal to 0, I less than m, I plus plus nums1 of dp of I0 will be having a length 0 only. Similarly, for int j equal to 0, j less than n, j plus plus, dp of 0j will be having a length of subarray 0 only. So this will be the base case. Now I will have a answer variable int answer equal to 0. Now what we can do is we can try to memorize the solution. We can try to run it as a for loop, run it as an iterative manner. Here the in iterative manner from from 0 it is going till m, so that we have to write it in opposite fashion. So in I equal to m minus 1, I greater than or equal to 0, I minus minus. Similarly, for int j equal to n minus 1, j greater than or equal to 0, j minus minus. And copy paste the recurrence relation. Just copy to paste this code. If my nums of 1 of y is equal to nums 2 of j, then the equal elements will be 1 plus dp of I plus 1 j plus 1, or else there will be two cases. Either these two cases can be these two cases are actually for the these two cases are just actually for they taking all possible ways, so we can eliminate in our recursive way, and we can just say dp of I j to be 0, and here we can just store dp of I j, or else to be more clear we can eliminate this part and we can just store dp of I j equal to equal elements. Else we can say dp of I j is initially 0. Here the dp of I j is calculated to be 1 plus this one, and we can eliminate this code as well. So here actually what we are doing is we want to eliminate this code, we don't want this, and this dp of I j answer should be maximum of answer comma dp of I j, and this also we can eliminate it. And obviously we don't want this code itself, we are declaring the whole size of dp itself to be 0, and this is m plus 1 and n plus 1 because I'm accessing I plus 1 and j plus 1, so I'm keeping it as an index extra 1, and finally I'm just returning answer. So now let us try to run our code. This is an iterative approach, so let us eliminate this code as well. So this is the bottom up approach, and we can submit our code. So yeah, this is the tabulation form, and hope you like this video. Let me know in the comments. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.